Today we are going to be talking about constants of proportionality. Our content objectives today will be students will be able to determine the constants of proportionality in a word problem that they will create. They will also determine the equation k equals y over x with a real world problem. Students will create a word problem and then write the equation and make a table and then a graph and then graph the equation for their word problem. Students will write their word problems. Oh, this is our language objective. Students will write their word problems using basic vocabulary that they already know, as well as newly learned content-based vocabulary. An example is the constant of proportionality, and a few that we will talk about in the next few slides. Students will be supported by being given visuals of the finished lesson, as well as the teacher using simple language and speaking at a slower pace. What are we doing today? So in this lesson, students will review solving for a variable in an equation. Students will also review graphing from a table. In order to complete this activity, students will be able to create a word problem, including newly learned vocabulary, and show a visual representation of their understanding. This objective will allow students to connect mathematics to their everyday lives and see how knowing how to set up and solve these problems, that it will be beneficial to them. The key vocabulary for this lesson, the first one is the constant of proportionality. So that is defined as the ratio between two directly proportional amounts. So kind of breaking down that definition, we can jump into ratio right next to it. And a ratio is a way to show the relationship or compare two numbers of the same kind. We use ratios to compare things of the same type. So speaking of relationships, we're going to jump down here. Relationships are just how the numbers are related, or how they compare to each other. And kind of similarly, the constant of proportionality definition, let's jump over to proportional. Proportional, it just means having a direct relationship to something in size, number, or amount. And then also we will be seeing determine today, which just means we're going to find or solve. Okay, so for our warm-up, you're going to be put with a partner, and you're going to answer this question. What do you know about proportions? This is a topic that we've previously discussed. I think this was discussed this is a 6th grade topic, proportions, so you can look back in your journal to see if we can jog your memory on that. And then you're going to think, pair, and share with your partner. You're going to think on your own, think of your own answer, and then share your answer with your partner, and come up with a short summary of both of your answers to the question to share with the group. And then we're going to watch this video as a quick kind of review and intro into our lesson. Okay, so I'm going to be playing this video, and throughout the video it will kind of stop and ask some questions. When it's asking the questions, I'm going to have you talk with your partner, and then I'm going to share one of the answers and see if you and your partner got the same or a similar answer.
In this town, where you need a clown for your kid's birthday or bar mitzvah, there's only one number to call, my number. And at $10 an hour, I got this clown game on lock. Being a clown isn't just funny business, I found a way to make it a money business. Check it out, here's the table I made. It shows how long I work and how much I get paid. If I work 2 hours, I make 20 bucks. 3 hours is 30, wait a minute, hold up. Divide my total earnings by the hours I clown. I always get the same number, 10, holy cow. Each ratio is equivalent. which tells me that the relationship between the hours I work and the dough I make is proportional. Okay?
So take a second to answer this with your partner. So the question is, explain how the clown can figure out how much money he'll earn for any number of hours he works. And my answer would be by using his constant that he figured out, which is 10. And remember that when we're doing a proportional relationship, you're multiplying. So we're not going to be adding anything. So we know that if it is proportional, we're going to multiply. So that's how he knows. He's going to take however many hours he works and multiply it by 10, and then he'll get the amount of money.
Let's call this column X and this column Y. Those are variables, they can vary in size. To get from X to Y, I multiply by the same exact number every time. That number's the constant of proportionality. You could call it constant though, casually. If X times a constant is always Y, the relationship's proportional and that's no lie.
So this question is, in your own words, explain what makes a relationship proportional. So this kind of goes back to the definition we just read about proportional. So we can look back on that. And remember, again, so proportional just means the relationship between the numbers.
This is proportional, is that right? X times the constant, K is Y, and if I graph it, then I'm gonna find a line straight through the origin every time. This is proportional, is that right? X times the constant, K is Y, and if I graph it, then I'm gonna find a line straight through the origin every time.
Okay, this next one, come up with a real-life relationship that the values in this table and graph could represent. My real-life example would be gas prices. So if gas is $2.50 a gallon, 1 gallon would be $2.50. And then if I wanted to say if I needed 5 gallons, that would be $12.50 because I would be multiplying by my constant of $2.50.
These big red shoes don't buy themselves. This graph shows how I make money myself. I took the values from my table, then I arranged them as ordered pairs on the coordinate plane. I plotted them, connected the dots, and then got a straight line going through the origin. And that made sense. The origin is 0, 0, and 0 hours times 10 equals no De Niro.
What does the point 440 on this graph represent? So the 4 in our chart is going to represent the hours worked, and the 40 is going to represent the earnings.
Proportional relationships always make a straight line and go through the origin every time. There's an equation to explain my pay. Start with the constant, we'll call it K. We found it by dividing Y by X. Let's multiply both sides by X. That's what's next. That's the equation for proportional relationships. Y equals KX. My constant is 10, my unit rate. So plug that into the equation for K.
This question is, what does the clown mean when he says unit rate is 10? How does his unit rate relate to the constant of proportionality? So like I had said, unit rate and a lot of the kind of words describing this kind of same equation is a 6th grade skill. Unit rate is the ratio between x and y, which is very similar to our constant of proportionality, which would be 10 in this one.
Y equals 10x. We nailed it now. When it comes to bank rolls, I'm not playing around. And sometimes the party host give me a tip. I made a table of my pay and it looks like this. Is this proportional relationship? Well, I'm gonna graph it, that's one way to tell. The line goes through the origin, but it's not straight at all. So the relationship is not proportional.
Describe another method besides graphing that you could use to determine whether or not this relationship is proportional. Other than graphing, one that you could use is to look at the y column and see if you can find a consistent pattern between the numbers in the y column. With this one, there is nothing that you can multiply by any of these to get this sequence of numbers.
I gotta say yes, this is proportional, is that right? X time the constant, K is Y, and if I graph it, then I'm gonna find a line straight through the origin every time. This is proportional, is that right? X time the constant, K is Y, and if I graph it, then I'm gonna find a line straight through the origin every time.
Okay, so that was a good kind of review, kind of intro into our lesson today. So right now you should have out your graphic organizer. It's going to look like this. And what parts are going to be in our foldable is you're going to see verbal description, which is going to be our word problem. You're also going to see the table column, and that's our X and Y chart. And then we're going to have a graph section and an equation section. And throughout our notes, I'll stop and ask you to rate your understanding by holding up 1 through 3 on your fingers. So if you hold up the number 1, that means that you need it to be explained again. 2 means that you're understanding it okay, but you still need some more explaining to understand it. And 3 is you feel like you'd be able to teach it to a friend. Okay, so our first example is the tax on soda is 3 cents per ounce. Okay, so when I'm looking at this, I'm thinking per one soda, if I have one soda, the tax on it is only going to be the 3 cents per ounce. Okay, so let's start looking at our table. I'm thinking, let's start with 0 ounces. So, if I have 0 ounces of something, and so if I have no soda, am I going to be taxed on the 0 ounces of soda I have? No. So, if we have 0 ounces, we're going to have 0 cents. We're not going to owe any money. And if I have 1 ounce, I'm going to take the 1 and multiply it by 3, which will be 3. So if I have 1 ounce of soda, I'm going to have 3 ounces. I'm going to have 3 cents that I'm going to owe. Now let's do 2 ounces. 2 ounces times 3 cents is going to be 6. Okay, and then we'll keep going. 3. And then I'm going to have 9 cents that I will owe. Okay, so remember, this is going to be multiplying. So when we multiply by 0, we're going to get 0. If we multiply by 1, we're going to get itself. So if you're looking at these and you see a 1 in any of the examples, you can know that whatever this one is, that is probably going to be your constant. So since we know it is proportional, we know that it goes through the origin, right? The origin is going to be the 0, 0. This is our X, and this is our Y. And we're going to make ordered pairs out of these. So our first ordered pair is the origin. Our next one is 1, 3, and then 2, 6, and then 3, 9. And we're going to draw our line. It should be straight. But looking at that, knowing that it's going through the origin and that it should be making a straight line, we know that it's proportional. So now we're going to go over to our equation, which is going to be y equals kx. And let's go ahead and replace these for our specific problem. So we're going to use for our y, let's use C for cents. Our cents, and we'll go ahead and keep the k. Okay. C equals k, and our x is going to be our ounces. So, in order to get the k to the other side, we're going to have to divide the O by the C, so we can get k by itself, which gives us k equals cents over ounces, which is also equal to k equals y over x. So let's go ahead and do a quick rate your understanding. So you're going to show me a 1, a 2, or a 3 on your chest. Okay, so I have a few 1s, a few 2s, and a few 3s. So if you are a 3 and you have a 2 around you, see if you can explain to your partner. See if you can figure out what they are confused about. If not, show me a thumb sideways and I will come answer your question. So in this next example, we are given the table and that's all. So we're going to have to come up with a word problem to match our table. So a way that I would do this is just to look at what they have. Not all of them are going to be labeled. The X and Y axis, which let me label that. X and Y here. So our X is hours and our Y is in miles. Well, I am having some technical difficulties on that one, so let's just talk through it and you can work with your partner to come up with, help me come up with a word problem for this one. So it is giving us hours and miles. We can see that it has an origin point, so we can already assume that it's proportional. It goes from 2 to 4, 4 to 8, 6 to 12. And we also see a pattern in the Y values, so 0, 4, 8, 12. Okay, so I know that my constant of proportionality is going to be 2. So let's go ahead and write down our equation. I'm not able to write it down, it's not working, but you guys can go ahead and write it down. So we're going to do an H for the X and an M for the miles. So that's going to look like M. Oh, there it goes. So that's going to look like M equals, there we go, K, H. There we go. Okay, and let's go ahead and get it to where the K is on the other side, so we know from up above we're going to we're going to do an equal action, so that means we're going to divide the h from this side, divide it over here. So k equals m over h. And let's go ahead and plot on our graph. So we know it's an origin. Our next point is 2, 4. Next is 4, 8. And we do not have a 12, but we know it's going to be somewhere up above the line. So we're going to go 6, 12. Let's see if I can do a straight, whoa. Let's see if I can do, nope. Okay, close enough. So now let's come up with a word problem. So we've got hours and we've got miles, and we know that our constant is 2. So I would think, so 2 miles in 2 hours is not something that a car would do. So let's give the example of walking. Okay, so we'll say I was walking 2 miles per hour. So if I was walking for 2 miles for 1 hour, if I walked for 2 hours, that's 4 miles. If I walked for 4 hours, that's 8 miles. Okay? And last, let's go ahead and rate our understanding one more time.